For decades, we believed the space around us was mapped, its dangers known, its wonders charted. But just recently, astronomers stumbled upon something that changes everything. A black hole weighing the mass of 600,000 suns, lurking quietly, right next door. No blazing light, no dramatic warning, just silent, invisible gravity hiding in the dark. It's been sitting there in a nearby dwarf galaxy, unnoticed for who knows how long. A monster in the shadows, quietly bending space and time. Imagine it. This cosmic giant, powerful enough to swallow stars, was invisible to our eyes, concealed behind a curtain of darkness. If we hadn't been looking with the right tools, we might never have seen it at all. What else is hiding in the silence of space? How many more of these sleeping giants surround us? In this video, we'll explore how scientists discovered this hidden black hole without a shred of light, what it means for our understanding of black holes in small galaxies, why its location is far more important than we think, and what it could reveal about the future of our cosmic neighborhood. Black holes are known as the most mysterious and powerful objects in the universe, but most of the ones we've studied are either supermassive monsters in the centers of galaxies or stellar mass, remnants from collapsed stars. This one, however, doesn't quite fit. Located in the Leo dwarf galaxy, a faint satellite galaxy that orbits the Milky Way just 820,000 light-years away, this black hole isn't just unusual, it's unprecedented. Leo Y has long been considered an unremarkable patch of stars, barely visible even through powerful telescopes. It never stood out. That is, until recently. Astronomers using the Gemini North Telescope in Hawaii noticed something strange in the motion of stars within Leo Thirster. Instead of moving in calm, predictable orbits, the stars near the center were speeding up, pulled by something invisible, something incredibly massive. At first, scientists thought it might just be a cluster of stars, but the data told a different story. The acceleration was too extreme. The only explanation? A black hole hundreds of thousands of times more massive than our Sun, sitting silently in the galaxy's heart. What makes this discovery even more remarkable is that there's no light, no radiation, no X-rays, no heat, nothing that we typically use to detect black holes. It's completely dark. This is the first time astronomers have found such a large black hole in a dwarf galaxy without any visible activity. It's as if the universe left us a cosmic ghost, hiding in plain sight. And it raises a chilling question. If something this massive was hidden so close, what else are we missing? To understand why this black hole is so shocking, we need to unpack how these cosmic giants are usually found. Most black holes reveal themselves through violence. They tear apart stars, emit jets of X-rays, or produce gravitational waves when they collide. But this one did none of that. It didn't roar. It whispered, through gravity alone. So how did scientists spot it? It all comes down to motion. Picture a spinning carousel. If one horse on the edge suddenly speeds up or swings out, you'd know something was pulling it harder. That's exactly what astronomers saw in Leo Thwernen. Using the Gemini North Telescope, they tracked the speeds of stars near the galaxy's center. The deeper they looked, the faster the stars were moving, much faster than gravity from visible matter could explain. This strange behavior pointed to something incredibly dense and powerful, yet completely invisible. This is where the science gets wild. Normally, black holes form when massive stars exhaust their fuel, collapse inward, and explode in a supernova. But this black hole is far too massive for that process alone. It belongs to a class called intermediate mass black holes, a cosmic missing link between stellar mass black holes and the supermassive giants at galactic centers. We've long believed they must exist, but until now, solid evidence has been rare. What's even more exciting is how this discovery reshapes our understanding of galaxy formation. if a dwarf galaxy like Leo I can harbor such a massive black hole. Maybe black holes formed before galaxies and actually helped build them. It flips the timeline we've trusted for decades. Telescopes like Hubble and instruments like the European Southern Observatory's Very Large Telescope played a crucial role in confirming this. And as gravitational wave detectors become more sensitive, we might even hear echoes of collisions involving these hidden monsters. This finding isn't just about one black hole. It's about rewriting a chapter of cosmic history. We're realizing the universe may be littered with unseen giants, shaping galaxies silently from the shadows. And now that we know how to find them, we might be on the brink of uncovering an entire hidden population. Now, you might be wondering, if this black hole is so massive and so close, is something dramatic about to happen? Could we witness it devouring stars or triggering a cataclysmic explosion? The answer is maybe, but not in a way we can easily predict. In space, time moves differently. Leo the Früher is about 820,000 light-years away, meaning what we're observing right now actually happened 820,000 years ago. So, if anything violent occurred, like the black hole pulling in a star or merging with another black hole, it might have already happened. We're just waiting for the light, or gravitational waves, to reach us. In a way, our telescopes are time machines, peering into a past we're only just beginning to understand. While this particular black hole appears quiet now, that could change in an instant. All it takes is one wandering star to drift too close. If that happens, the gravitational pull would tear the star apart, releasing a burst of radiation powerful enough to outshine entire galaxies. The resulting light show could be so bright it might even be visible from Earth, possibly shining as bright as the full moon, maybe even during daylight hours. We're not saying it will happen tomorrow, but the potential is always there. And because this black hole is practically in our cosmic backyard, we'll be watching it closely, ready for any sudden flashes, wobbles, or ripples in space-time that might signal the beginning of something extraordinary. Imagine stepping outside one night and noticing a strange new light in the sky, brighter than anything you've ever seen. Not a star, not a planet, but something unfamiliar, glowing with an eerie intensity. It grows night after night until it outshines the full moon, casting shadows on the ground and painting the landscape in a soft, silver-blue glow. This isn't science fiction. This is what we might witness if the black hole in Leo 1 suddenly began feeding, tearing apart a star and unleashing unimaginable energy into space. We'd see a flash, an enormous burst of light and radiation, traveling across the universe for nearly 1,000,000 years, finally arriving at Earth. Depending on the intensity, it could be visible to the naked eye for days, weeks, even months. Observers across the globe would be able to watch it, no telescope needed. It might pulse or flicker, changing in color and brightness as the black hole devours its prey. Astronomers would scramble to study it in real time, while millions of people simply looked up in awe. It would be a cosmic spectacle not seen in recorded history, a once-in-a-civilization event. For a brief moment, we'd all be united by a single sight in the sky, a reminder of how small we are, and how breathtakingly vast and mysterious the universe truly is. Discovering a black hole like this, completely invisible yet so massive and close, isn't just exciting. It's a scientific jackpot. These rare giants hold the keys to some of the biggest mysteries in astrophysics. For years, scientists have searched for intermediate mass black holes, the missing links between small stellar remnants and the colossal supermassive black holes that anchor entire galaxies. Now, with Leo V's dark monster, we finally have a live specimen. Studying its effects on nearby stars, its environment, and any future outbursts could teach us how galaxies form, evolve, and possibly even how the first black holes came to be. But it goes deeper than just understanding space mechanics. When black holes feed or collide, They release powerful jets and radiation, and sometimes even trigger colonovae, explosive events that forge the universe's heaviest elements. Gold, platinum, uranium, the stuff of wedding rings, and nuclear fuel is born in these violent moments. It's cosmic alchemy on the grandest scale. This means that, quite literally, parts of us, our bones, our blood, the metal in our phones, were once inside ancient stars that exploded long before Earth even formed. Every atom of carbon in your body, every molecule of oxygen you breathe, was forged in a furnace millions of light years away. This black hole, silent as it may seem, is part of that same cosmic cycle. It reminds us that we're not separate from the universe. We're made of it. Stars like Antares or VY Canis Majoris may seem distant and untouchable, but their fate is our origin. And with every new discovery, we're not just learning about space, we're remembering where we came from. Despite how dramatic and powerful such an event might sound, there's no need to worry. Earth is completely safe. Even if this black hole were to suddenly devour a star in Leo Thurin and unleash a massive outburst, it's happening over 800,000 light-years away. That's well beyond any danger zone. The light and radiation would arrive peacefully, more as a cosmic show than a threat. In fact, the only real effects we might notice here on Earth would be purely atmospheric, and even those would be subtle. We might see brighter auroras near the poles or slight changes in the ionosphere, the upper layer of our atmosphere that reflects radio waves. But these would be harmless, and to scientists, deeply fascinating. What's even more impressive is that we might get a heads up before anything even becomes visible. Thanks to advanced neutrino detectors, like Japan's Super Kamiokande or the Ice Cube Observatory in Antarctica, we can detect ghostly particles called neutrinos that escape from stellar events long before light does. These silent messengers would trigger a global alert among astronomers, giving us hours or even days of advance notice to point our telescopes to the right spot in the sky. So if something spectacular is coming, we'll be ready. We're witnessing the final breath of a giant, a farewell millions of years in the making. Hidden in the shadows of a faint galaxy, this 600,000 sun black hole has quietly shaped its corner of the cosmos, unnoticed and invisible, until now. Its discovery is a reminder that the universe still holds secrets, even in places we thought we'd already explored. Time moves differently out there. What we see today is ancient history unfolding in the present. The light from Leo. I's black hole began its journey long before humans walked the Earth, before the first spark of civilization, before the continents took their shape, and yet it reaches us now, like a whisper from the past echoing through eternity. In a universe so vast, it's easy to feel small, but it's in these moments when we uncover something so distant, so powerful, so mysterious, that we feel deeply connected to the cosmos. We are stardust, born from the remains of stars that lived and died billions of years ago, and every discovery like this brings us a step closer to understanding where we come from and where we might be going. So keep looking up. The night sky isn't just filled with stars, it's filled with stories, and some of them are just beginning to be told. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. Join us on this cosmic journey. There's so much more waiting to be discovered.